In the early universe, when the first atoms were just beginning to combine into structures and gravity was shaping the first galaxies, scientists believed that the cosmos was filled with small, chaotic clouds of gas. However, the James Webb Space Telescope has discovered something that completely contradicts this picture: massive galaxies that shouldn't even exist yet. Dubbed red monsters by researchers, these gigantic structures seem to defy everything we know about cosmic evolution. How is it possible that at a time when galaxies should just be forming, enormous systems with masses comparable to the Milky Way already existed? What if everything we know about galaxy evolution is wrong? And what if our model of the universe has major gaps, and this NASA discovery could completely change it? If these galaxies truly exist, science may be facing its greatest challenge since Einstein. Let's take a closer look. What did the James Webb Telescope actually discover? We're talking about 3 galaxies whose light has traveled to us for over 12.8 billion years. In other words, we see them as they were just 800 million years after the Big Bang. The problem? At that time, galaxies should have only been in the early stages of formation. Yet these monsters have masses comparable to the Milky Way. It's like discovering a fully developed modern ecosystem with forests, rivers, and complex organisms during a time when life on Earth was just beginning to form as simple bacteria. Something clearly doesn't add up. Why is this so surprising? According to modern cosmological models, galaxy formation is a long and gradual process. Initially, the early universe was full of hot, dense plasma, and the first hydrogen and helium atoms only started forming hundreds of thousands of years after the Big Bang. Over time, under the influence of gravity, matter began to condense into small gas clouds, which gradually grew and merged, giving rise to the first galaxies. The problem is that these processes take time, and the young universe simply didn't have enough of it. According to current models, there was no way such massive galaxies could have formed just 800 million years after the Big Bang. They should have still been in their infancy, yet they appear to be fully developed, with masses comparable to the Milky Way, which took over 13 billion years to form. This discovery is like archaeologists uncovering modern cities filled with skyscrapers and advanced infrastructure in an era when humanity was just beginning to settle in caves. The time gap is so enormous that it seems impossible, suggesting that either our galaxy evolution models are flawed or there are unknown processes that allowed these galaxies to grow much faster than expected. What are the possible explanations? Scientists are actively searching for answers to this mystery and are considering several possible scenarios. Galaxies may have grown much faster than we thought. Perhaps the conditions in the early universe favored the rapid formation of stars and mass accumulation. Dark matter may have played a different role than we assumed, accelerating galaxy formation. Our distance measurement methods may be inaccurate. It's possible that these galaxies aren't as old as we think. Errors in analyzing redshift or interference from cosmic dust could be distorting the light reaching us from these distant regions of the universe. Physics may have worked differently in the early universe. Some radical proposals suggest that the fundamental laws of physics may have operated differently. Perhaps gravity itself behaved differently, allowing galaxies to accumulate mass more quickly. Or maybe there was an additional phase of cosmic inflation that we haven't yet accounted for in our theories. What does this mean for cosmology? Regardless of which theory turns out to be correct, one thing is certain: the red monsters force us to rethink how the universe truly formed. This discovery challenges astrophysicists to reconsider many fundamental assumptions about galaxy evolution. It's possible that our current theories are incomplete, and there are processes we still don't understand. Will we need to completely revise our models of galaxy formation? Or is this just a local anomaly that we'll soon be able to explain? Perhaps the universe is far more dynamic and unpredictable than we ever imagined. Thank you for watching and exploring the mysteries of the cosmos with us. If you enjoyed this content and want to stay updated on the latest space discoveries, subscribe and click the bell so you don't miss our next fascinating topics.